Good morning, guys. I'm Gauri Shiram. So now I'm going to talk about the Dsp laboratory examination problem statement. So the problem statement given here is to design a pulse rate measurement system that will be automatically measuring the pulse rate from the PPG signal. And the catch here is that the PPG signal given has corrupted baseline frequencies of DC up to 0.5 Hz, and also the power line interference of the instruments that are which is greater than 20 Hz, and all these are the noises that are present in the PPG signal. We need to calculate the pulse rate from the PPG signal that has been given to us. So, and also we need to draw the block diagram. We need to suggest two approaches for a complete explanations, and also we need to provide the Arduino programming. So I will explain one by one. So coming to the explanation part of the program. So here the given PPG signal consists of noises. The noises are baseline drift component, instrumental noise, and also the power line noise. So you can see the baseline drift component has a frequency less than 0.1 Hz, and the instrumental and the power line noises are more than 20 Hz. So we have the PPG signal. We need to procure the PPG signal which is between these noises. So as we can see, we need to use a band pass filter to isolate the PPG signal, and then we need to measure the pulse rate measurement of the PPG signal to get an accurate reading. So without filtering is the first step that we need to do here. So coming to the block diagram. So seems it's the block diagram was inverted. I'll explain. So this is the input signal of our signal. So this is the first process that I am going to explain. So this is the input signal of our signal. This is the band pass filter which acts as a filter for our PPG signal. So then we apply the autocorrelation function. Autocorrelation function is it is a correlation of a signal with a delayed copy of the signal function itself. So it generally makes or smoothens the signal of our system. So coming to them, then we can have a zero crossing point. So zero crossing point is that we measure the.
Hello, sir. Hello, sir.
Yeah.
Sir, can you just check?
So the thing here is that we need to find the zero crossing point. The zero crossing point is such that the PPG signal that we have obtained will be like this. So we need to find the zero crossing point here, and we need to find the peak here. So by finding and defining the difference between these 2 points, we will find the time period, and thereby finding the frequency of the system. So coming to the calculation part, I will explain in 1 second. So coming to the explanation part. So here you can see, so the band pass filter is given 0.5 to 5 Hz, and then we need to use a Butterworth first order kind filter, which is like the IRF filter. So H of S is equal to 1 by S plus 1. So the transformation from low pass filter to band pass filter can be done by S tends to S square plus omega naught square plus S omega, where omega of lower one and omega of higher one, these two will omega and omega naught, and these two are given here. So coming to the omega of lower, we need to find 0.5 by fs into 2 pi. Will be higher, and omega of higher. So these two are the lower and the higher frequencies that we need to stop by using the band pass filter. So we can calculate from mathematically the equation that we get from here. So H of S is equal to S omega by S square plus omega naught square plus S omega. So we have the frequency of lower and higher frequency that we need to keep for the band pass filter. By applying the H of S, the equation will become like this. Then S is equal to 2 pi by, and then after all the calculation we can get the equation as, and this is the transfer function that we obtain for the given system. So this is for this we need to give the input. We will get the output of function which is the pulse, and then we need to apply the zero crossing point and autocorrelation for finding the frequency. So YFM, this is the difference equation of the function. So coming to the Arduino code. So Arduino code here has been written here. So initially we are taking the pulse X. We are initially taking big array of X. So we have everything, the function, the input signal that has been given here in the set of values. So the serial dot beginning, the making the Arduino to begin our project. So then we have a of void loop. So here you can see, after the consideration of doing the above thing, the band pass filter, we will be getting the function x of 100, x of 1000. So we will be storing in x of 1000 array. then we will be doing autocorrelation function. So autocorrelation function is R of m equal x of m into x of n plus m, where n tends n is equal 0 to n minus m minus 1. So here we are doing the same thing, which will be helping us to reduce the so this will be helping us to reduce the and making our signal to be smoothened. So once this part is done, after the band pass filter and also the autocorrelation function, we will be getting a signal where we need to find where we will be getting a periodic type of signal, and hence we can find the time period and frequency of signal once we get for a small certain period of time. So here we are this is a part for the autocorrelation part. So once the autocorrelation function is done, we will be getting a nice some signals like this. So after this we need to find the time period of the each thing. So for that we need to find the zero crossing points. So zero crossing points are these points where we need to find where the graph is approaching from negative to positive. So for applying the zero crossing point, we have been applying this condition where x of I into y of I plus 1 is less than 0. So once if there is a graph like this, and once if this is positive and this is negative, so once multiplying them will give us a -1. So this gives a zero crossing point, and then once when we get a first zero crossing point, we are storing that value in that index. So after then once we get the index of that value, we need to find the peak, which will be next then. So we are again making the for loop to run from this index to next to 2000. So once we get a maximum value, we will be storing in that peak. So next part of the Arduino code has been, next part of the Arduino code is we have the peak value and we have the index value. We can find the time period of this by subtracting the both of them. So once we have a time period, then we can find the frequency and all from the simple formulas that we have. So this is a part for finding the frequency pulse rate by of the PPG signal. So another part we have this from FFT, which this also has the same kind of principle where we need to use a band pass filter, and also this directly we are using FFT thing. So coming to the these are all the equation we have used. So this is a band pass filter. We have the frequency this 0.5 to 5, and another we have used a Butterworth first order filter, which is IIR filter here at H office, and this is all the mathematical proof that we have. So given S and S square plus omega, this is the equation that will be transformed. This is a transform H of S that has been we are finding the initial lower and the higher frequencies by applying the lower and the higher frequencies that we have of the band pass filter. So once we have this, we have the lower and higher frequencies which we need to apply for band pass filter and all. So and then after the mathematical, so this equation will give us a mathematical derivation of how we need to implement this in paperwork and all. So this coming to the explanation of this, we have the first transfer function H of S, and then we have applied the lower and the higher frequencies that we need to apply to the transfer function. So this is so after applying the band pass filter, this is the thing that we have applied. So this we need to find out, and then we need to apply the autocorrelation function, the autocorrelation function, and this zero crossing point to find the time period. And and then once we get the time period, we have frequency formula that is equal to 16 to 1 by time period. Then we can find the frequency of the such thing. So we need to draw the functional chart of the proposed system. We need to as you can see, the block diagram has been inverted. I'm going to explain from here only. So this is the input signal that we have given. After we are passing the band pass filter, we will be getting a signal. Where we have removed all the noises like baseline, drift component, power line, instrumental noise, and power line components. So as we are using band pass filter because we have unwanted frequencies between a certain limit, and also we have unwanted frequency after a certain limit. We need a frequencies in between a certain interval of time. So for getting those values, we are using the band pass filter. So coming to the autocorrelation function, it's generally it is nothing but it is it is nothing but the correlation of the signal with a desired copy of itself. So the need of autocorrelation is here we are getting if there are any as we are obtaining signal from hardware, there might be some issues where there might be some handling and all that we use high frequency components in the that will give a wanted high frequency components in them. So in order to smooth them all those things, we need to use a autocorrelation function. We also use a moving average filter which also acts as a low pass filter. Here there also we just multiply with the delayed version of itself by 1 second itself by one thing. X of n is y of n is equal to x of n into x of n minus 1. Here we'll be here we will use the formula r of m is equal to 1 by r naught into sigma x of n into x of n plus m. So this autocorrelation function or either moving arrow filter, they makes the graph to be smoothen. So once this autocorrelation function is done, we will be getting a plot that will be almost periodic in nature, and thus we need to concentrate on single part, and then we can, once we are concentrating on a single part, single period, then the rest of the mathematical calculation will be same for all because it is a periodic function. Coming to the zero crossing point is a thing that is a technique that we are applying here to find the pulse rate, that is the time period of the obtained signal after the autocorrelation function. So the zero crossing point is that, so once we will be having a functions like this. So here once we are obtained, so here we are obtaining this point where the function crosses the 0. So after crossing this, we will be obtaining this. Once we get this point, then we will be obtaining this peak. So after this will be same for every period of interval, which will be repeated like this. So once we get the difference, we will find the time period, and then we will find the frequency of that component. This can be explained well in the Arduino programming, as I have explained here. See. So for finding the zero crossing point, we will be using this formula x of I into x of I plus 1 less than 0. So this gives a zero crossing point. Once zero crossing point is found, this will be stored in the index which is a variable that has been declared before. So once in this index we have the point where it has a zero crossing point. So once the zero crossing point is done, our focus should be shifted to find the peak of that signal. So the peak of the signal can be find from just it's not needed to iterate from 0 itself. Then we can directly start iterating from the zero crossing point. So from this zero crossing point, we start iterating to find the maximum of the signal, and once we find it, we will find it and we will store it in the peak, and then we will find the difference and we will get the time period. From the time period, we are getting the frequency. So this is all about our part. So thank you.